In this problem, I'd like to go over how we can set up a system of equations, of linear equations, to help us solve word problems that have two unknowns. So here we're given an example. Two wings of a hospital have a total of 45 patients. The east wing has 5 more than the west wing. How many patients are currently in the east wing? So first of all, just like if you saw my video with the one unknown, we want to just try to think about not jumping into the problem, but just first conceptualizing what our unknown quantities are, because many times we need to introduce variables that represent those unknown quantities. So just looking at this problem, the two things I don't know in this case are the number of patients in the east wing, but I also don't know the number of patients in the west wing. So those are the two things I don't know. So I don't know the number of patients in the east wing. That's the question I'm asked to find. But I also don't know, in this case, the number of patients in the west wing of the hospital. Those are the two things I don't know. So just like we have seen before, these are where our variables are going to come in. These are the quantities we don't know. So how can we address this problem with only one variable? Well, let me bring this down here. Now we need to, as we saw in the previous video, if you saw it, we need to introduce a variable. So here we don't know first the number of patients in the east wing. So I'm going to let x equal the number of patients in the east wing. And I'm just solving this using one variable. So number of patients in the east wing. Now I also don't know the number of patients in this case in the west wing, but I can't use x again, because if I use x again, well, if x equals the number in the east and x equals the number in the west, then you're assuming that they're equal. We don't know that. So one thing that we could do is just use a different variable. And in fact, we're going to see that coming up, where I'm going to use a different variable. But the other thing you could do is to use x and the relationship between the east and the west wing. So let's think if we're given any information between the east and the west, and it says the east wing has 5 more than the west wing. The east wing has 5 more than the west wing. So that means up above here, the east wing has 5 more than the west wing. So if I take the east wing and I take away 5 patients from that east wing, that's going to equal the number of patients at the west wing. So I'm just thinking about this without any variables or anything. But since it has 5 more, right, the east has 5 more, we need to take those 5 away, and then it will be equal. These quantities will be equal. The east wing, take away 5, then it will be equal to the west wing. So what can we do down here? The number of patients in the west wing, well, that's just the east wing minus 5. The east wing is x. So let's take that x, take away 5, and now we have two quantities here that represent the information in this problem. We don't know the number of patients in the east wing. We called that x. Now if I take 5 of those patients away from x, that's how many are in the west wing. I got that from the information in the problem. Now what else do we know in this case? In the problem, we're told the two wings have a total of 45 patients. So if I take these two quantities, if I take the east wing patients and I add that to the west wing, that's going to equal the total number of patients. Again, just writing this with words. Well, the east wing, we called that x. That's the east wing, the number of patients. The west wing we called x minus 5. And the total we know is 45. So I've arrived at a one variable equation, one unknown. So this is 2x minus 5 equal to 45. I can add 5 to both sides just using my one variable equations. Let me finish the problem up here at the top. 2x will equal 50. Once I divide by 2, x will equal 25. Now, what did you actually find there? When you found x equal to 25, what did we call x? X, if we go back here, is the number of patients in the East Wing. So there are 25 patients in the East Wing, which means if there are 25 in the East Wing, there are 5 less in the West Wing. There are 20 patients in the West Wing. So this is how we can introduce or solve this problem using one variable, one unknown. We can also set up what's called a system of equations. And in this case, and this is actually how I'm going to continue doing these problems, is I'm going to solve this where we don't just use x, but instead we write two equations with two unknowns. So in this problem, there were two unknowns, right? We didn't know the patients in the East Wing, so I'll still introduce x as the patients. And I'm going to start abbreviating here so the video doesn't get too long. I'm going to let x equal the number of patients in the East Wing. The other thing I didn't know was the number of patients in the West Wing. So let's just call this y. Let's introduce another variable. They could be equal. We don't know, and we turned out to be different. But let's use a different letter here. And now what we want to be able to do is to use this x and this y and see if we can given the information of the problem here, write two equations, write two different equations. And we can do that actually, right? We know that, in this case, the two wings of a hospital have a total of 45 patients. So that means if I take x and I add y to that, if I take the total number of patients, that's going to equal 45. That's the first equation. And we also know the East Wing has 5 more than the West Wing. And we actually found that. If we take the East Wing and subtract 5 from that, we're going to get the number of patients in the West Wing. Whoops, that should not be a y. Oh, it is. I'm sorry. I'm kind of getting all backwards here. If we take the number of patients in the East Wing, take away 5, then that will equal the number of patients in the West Wing. This is what we call a system of linear equations. We use a bracket here to say that these two equations are grouped together. We want these two to be inseparable. Now, how can we go about figuring out what this x and y is? And this is what we would call, and what we will call, the substitution method. That is, for this first equation, I know x plus y equals 45. But in this second equation, I'm told what y is equal to. Y is equal to the quantity x minus 5. So what I can do is actually take this first equation, and anywhere I see a value of y, I can pick up that y and replace it with x minus 5. Why? Because those are equal. Y is equal to this quantity. So I'm going to take this equation, x plus, and we're going to soon replace that y, but anywhere I see a y, I can replace that not with a y, but I can replace that with this quantity right here, x minus 5. Because this is called the substitution method. I know what y is equal to. Y is equal to this quantity. I can pick the y up, put x minus 5 in its place, and look what we have. When we combine like terms and solve for x, we actually have the same equation that we ended up having up above. And that should make sense. We shouldn't get two different answers. We solve for x, we get 25. What did I find? I found the number of patients in East Wing. That's what x was equal to. How can I find out what y is? Right? If I'm looking for x, well, what is y? Y is x minus 5. So let's take 5 away from that. X is 25. We'll take 5 away from that. That's going to give us 20. There are 20 patients in the West Wing. So again, this is called the substitution method. Up above, we actually did the substitution method. We just based it on our intuition. We didn't write out additional variables. But down here, we wrote our two unknowns. We introduced variables for those two unknowns, wrote two equations describing those, the relationship between those two unknowns, and then used the substitution method, plugged that in and solved for x, went back and solved for y. Now we're going to go over another example, and I'm going to focus and really actually go over these problems using this system of linear equations. I'm going to use multiple variables and this substitution method. Here are two more examples that I'd like to go over, and I'm going to solve these using a system of linear equations. Now, anytime you have, and we're going to really only focus here on two unknowns. We have two unknowns, which means we're going to need, if I can spell unknowns right, two unknowns, we're going to need two different equations. But before we jump into all of that, let's just read the problem, write down the two things we don't know, and see if we can write two equations. So Sean is in charge of twice as many patients as Ty. If they have a total of 9 patients, how many is Ty responsible for? You might be able to do this without any sort of algebra, and that is great. But let's practice this, setting up our unknowns, what our unknowns are, writing two equations, and solving a system of linear equations. So first of all, what are the two things that we don't know in this example? We want to be specific. If we go to where the question is how many, and I'm assuming, and we know that that's talking about the number of patients. How many patients is Ty responsible for? I don't know. So let's say let T equal the number of patients for Ty. If I can spell, which is not my strong suit, that's not spelling, that's just bad is what that is. Let T equal the number of patients for Ty. What else do I not know in this example? Well, I'm up here, if we look, Sean is in charge of twice as many as Ty. That means I don't know the number for Sean either. So that's what I'm going to let my second variable equal. Let's let S equal the number of patients for Sean. These are the two things I don't know in this example. Now I want to set up a system of linear equations. I want to use T and S and the information in this problem to write two equations. Now let's see if we can kind of summarize or underline where I'm getting this information. Well, first, I know Sean is in charge of twice as many patients as Ty, and they have a total of 9 patients. So I'm going to start with that second line, the total. I know if I take the number of patients for Ty and I add the number of patients for Sean, that's going to equal the total, which in this case is 9. So there we go. I know that to be true. The other piece of information I need to write an equation is this. Sean is in charge of twice as many as Ty. Now we want to be careful here because we want them to be equal. Sean is in charge of twice as many as Ty. So if I want these two quantities to be equal, I need to take Ty's patients, multiply them by 2, then that will equal Sean's. Now sometimes, and this is a common mistake, that students will read this 2S is equal to T. That's not correct. Here you're saying you need to take Sean's patients, multiply that number by 2, and then it will equal Ty's. And that's not the case here. Sean is in charge of twice as many. So if we want them to be equal, we need this equation to be balanced. We need to multiply Ty's number of patients by 2. So take Ty's, multiply that by 2, and we'll equal S. The other thing you could have done is actually take this S, take Sean's patients, and divide it by 2. Then it will equal Ty. That would have been okay too. Either one of those would have been appropriate. So now, if we look at our system of linear equations, T plus S equals 9, and I'm told S is equal to 2T. So what I want to do is use the substitution method. I want to look to see if one of my equations is already solved for one of the variables, and if I look, this one's great. I'm told exactly what S is equal to. So that means in any of the other equations, and we only have one equation, we only have this one other equation, anywhere I see an S, I can pick that value of S up and replace it with 2T. And that's what I'm going to do. Anywhere I see an S, I'm going to replace it with a 2T. So here, I'm going to write t plus not s, but s is equal to 2t from our second equation. So again, I know what s is equal to. I can replace, just physically pick up this s and replace it with 2t. And now I have, if you look over here, I have a one variable equation. T plus 2t, that's 3t's, equal to 9. T will equal 3 if I divide both sides by 3. What did I actually find? I found the value of t, which if I look above, I know that Ty had 3 patients. And I still need to find this value of s. Now, how am I going to find that? Go back to your equations. Go back to your equations. You now know what t is. T is equal to 3. So 3 plus some number equals 9. Well, that number has to be 6. All right, so you could either take that and put that here. We know what t is. T is equal to 3. In this case, if I plug that back into the first equation, s is equal to 6. That's great. Or you could plug that into the second equation. We know what t is. T is equal to 3 from what we just solved. Regardless of what equation you plug that in, we get s is equal to 6. So Sean has, or had, I'm not sure about the past or present here, but has or had 6 patients. So again, thought about the unknowns. I wrote 2 equations describing the unknowns. I used the substitution method to solve for my one unknown and then plug that back in to solve for the second. If you'd like to try the next problem, go ahead and hit pause the video and attempt it. This problem is a little bit more complicated. We're told we have a 2,000 milliliter vial of medication. It needs to be used for 2 patients. Jess is to receive 300 more than Lauren, and then 100 should be left in the vial. How much should each be administered? We said how much will be administered to Jess, but we want to look for both. So the 2 things I don't know in this case. I don't know the amount given to Jess, and I also don't know the amount given to Lauren. So those are the 2 things I don't know. So I'm going to write those down. And since these are the 2 quantities I don't know, I'm looking for, I'm going to need variables. If I were to introduce or describe these quantities into any equation, I'm going to need a placeholder. I'm going to need a variable to represent these quantities. So let's let J equal the amount given to Jess, and let's let L equal the amount given to Lauren. So what I want to do now is to be given the information in this problem, I want to set up and write 2 equations. So I'm looking for a system of equations using J and L, and I need 2. I must have 2. So first, let's see if I can go back and see if I can find information. I'm told Jess is to get 300 more than Lauren. That's telling me that I need to equate these 2 values. I need to equate what Lauren's receiving and what Jess is receiving. So if I take what Lauren was receiving and I add 300 to that, then it will equal the amount that Jess will receive. Again, that's a little backwards than you might see here in the problem. Jess is to get 300 more than Lauren. So let's take Lauren. We'll add 300, and then it's equal to Jess. That one's a little bit more straightforward, perhaps, than some of the others. We need to take Lauren, add 300 to that amount, and then it'll equal Jess. That's the first equation. But we're also told that this is a 2,000 ml vial, and once I administer the amount to Jess, and then I administer the amount to Lauren, then there's going to be 100 milliliters left over. So what that's telling me is, once I figure out how much Lauren is to receive, and then if I go and give the medication to Jess, there's going to be 100 left over. So if I add that 100 to those amounts, that's going to equal my total. So there's lots of ways that you could actually approach this problem, but this is how I thought about it. Let's give the amounts to Lauren, give the amount to Jess, and then I know 100 is left over. So if I add 100 to those 2 quantities, I'll have my total. And what I have here is a system of linear equations. Now what I need to do is I'm going to use the substitution method here. Is one of these equations solved for already for one of the variables? And the answer is yes. If we look at this first equation, we specifically know that L plus 300, that's the amount that Jess received. So J is equal to this amount. That's telling me in any of the other equations, which again, I only have one other equation, any of the other equations, anywhere I see a J, I can replace it with 300 plus L, or L plus 300. So that's exactly what I'm going to do. I'm going to rewrite this second equation, but I'm not going to write a J. Instead, I'm going to replace it with L plus 300, and I'm going to put it in parentheses here. I'm just putting that right here in for J. I still have the plus 100 equal to 2,000. So the only thing I did there was replace the J with the L plus 300. And now what do I have? I have a one variable equation that I can solve. So I have two L's, if I gather like terms. 2L plus, this is 400, 300 plus 100, equal to 2,000. Now I'm going to solve this just like I would any other one variable equation. 2L is equal to 1,600. L is equal to 800 once I solve that for L. What did I just find? I found that Lauren, that's the value of L here, Lauren needs to be given 800 milliliters. We need the unit here. Now how can I figure out what Jess is to receive? Well, let's go back and plug that in to one of the equations, and you can choose. You can choose to plug 800 in for L in the first equation, or you can take 800 and plug that into the second equation. You'll still be able to, regardless of which equation you use, be able to solve for the other variable. It's going to be a little bit easier if we plug that right here into this first equation. L is 800, so 800 plus 300 will equal J. J will equal 1,100. So here, Jess is to receive 1,100 milliliters. Okay, if you have questions, let me know.